The next thing that we're going to have you do, make sure that you sign in. Go sign into your calculators. Oh. Hang on. Are you all right?
Sorry about that. Oh my gosh.
Did you get pelted or no? Okay. Here.
Sorry.
I don't think I get you here. So we're good. Let's do this. You take your stuff. You didn't do it on purpose. Then we're good. All right. Okay. So make sure, please, now your homework should be out on your desk, and that you make sure, please, that you've signed into your calculator if you haven't already. Now, here are the answers to the homework. We're not going to spend. Here's one of the things that I guess is a little bit different. Some of us go through and we spent out. You already handed them up into. All right. In the future, this you can go back and check, and I'll send it out to you. Sometimes, and I know the drill, you do this slow burn where you go through and say, yeah, can we go over number 1, and I didn't get number 2, and then I didn't get number 3, and I didn't get number 4, and you end up, spending 30 minutes of class on something that should be done independently. So here are the answers. Did we hand this up and over yet or no? Okay. Here's your answers. What I advise you to do is this. If there's one that there's a discrepancy on, and you'd like to see it done again, go through and put a star next to it on the homework packet, not the homework sheet in front of you, but the homework packet. So you know, which one you have to ask questions about next time we meet. On ones that ask you for a graph, you can give just a sketch of the graph. But again, those are the answers. If you need to, you can actually go watch the video for them, pause it, and come back to it. We'll maybe get to one if we got one. Is there one? Go, Tyler, do you have one?
For number 38, I put it in slope.
If it didn't say, you can use either form. If it said slope intercept, then it needs to be y plus mx plus b. We'll give you another minute to look that over again. If you've got questions, just put them, star the questions themselves on the homework packet. I posted for you the note packet and the homework packet through the Google Classroom, so you're able to go through and access the file if you're saying that the font on it is too small. And I get it, and in the future we won't have them be that small. Questions on what we've got now? We got one, yeah?
Just thing is, I don't see a 40. Oh, wait a sec, sorry. Where's 33 and 30? Like, I see them, but did we have to do them?
Were they on there?
Well, it says pick 67 through 69, and it starts like right there.
No, and look at the section above it. It says find the slope of each of those lines.
Oh.
Right?
Can I do that quickly?
You make it quick. All right, and make sure, please, that you've logged into your calculators. Have out your unit note packets, please. We'll have you hand those. Make sure, again, your name is printed at the top of the homework. And let's have you hand those up and over now, please. Let's go, please. Have you hand your homeworks up and over right now. Take a minute, so you can hand it in. What do you mean? Out 3? You did it on 3? Okay. There's a stapler on my desk. You go and cut it. Guys, you're just handing in the homework. Why? You don't need to hand in the packet.
I wrote all my answers on the packet.
All right, get it to me by the end of the day, please. when you do your homework, guys, you don't do it in the packet, you do it on separate paper. Can we go over that? Didn't I mention the spaghetti, the octopus paper? When we do assignments in here, please make sure that you don't hand in octopus paper. That's one where when you like rip it out of the notebook and there's like tentacles emerging from the side. You have the wrong point, then that might be. Yeah, I think it does. All right, whoa! There's weight. Things like, one thing too, there's times where it's natural to have like a conversation, but literally if you're going like this with a sheet of paper, that's probably not one of those times. So make sure, please, again, are you looking for your thing? If you have your homework done, our homework is always done on separate paper. You're never going to be doing it on a sheet unless I tell you to do so. Make sure that your note packets are out on your desk for the third time. Make sure your note packets are out on your desk. We left off at topic 2.1. Thank you. Thank you. If you ever need paper, thank you. If you ever need paper and don't have loose leaf paper and need some, there's a ton of it over on the side. Thank you. No, do it on separate paper, Mike. Oh, you can hand it in later today then. Okay. If you ever need, thank you, separate loose leaf paper, there's about 10,000 sheets of it over on the side, the second shelf underneath the calculator. So make sure, please, if you need some, there's more than enough there. You can take some on your assignments. So as we do this, you all had indicated that you at least have some passing familiarity with what a relation is, what a function is, because you remember stuff like vertical line test. That's something that most of you had indicated that you were somewhat familiar with. Looking at this, the relation is a set of ordered pairs. It's a mapping of points. It gives you an input and then an output. A relation does not have to be a function. And it's represented by any of these. And again, you do not have to have a relation to be a function. Now, we're going to talk about what the domain is and what the range is of these. The domain is the input, the range is the output. So looking at the first one here, your domain, which is your input, is going to be 1. Actually, I say this, a personal pet peeve. List them out from least to greatest. So I list -9, 1, and 3. That is your domain. It's not all real numbers. The domain is just the inputs used by the indicated relation. Your range is going to be the output. So for range, we would go through and say the smallest one is 0, then 3, and then 5. You could also list it out as an x equals. When we go through and graph this out, this is going to be a line. It's linear because the x to the first, or the x is to the first. Now if I'm looking at this graph, here's a generic Cartesian plane, which is the xy plane. Just on a side note, raise your hand if you heard it called the Cartesian plane before this year. 1, 2 of you. You all came from geometry Enriched. What do they call it? XY plane? Okay. We're gonna, and again, this is not me trying to be a stickler. I'd rather correct it now. I really don't. It's not angry that you don't know it, but it's a little disturbing that you don't. In any case, as you come through, there's going to be a lot of stuff where I'm constantly correcting your language, and it's not personal. Fractions don't have tops and bottoms. Outfits do. Fractions have numerators and denominators. The expression under the radical is called the radicand. When we're talking about an input, we'll refer to it as an argument. we're going to go through, and when you want parentheses there, that's the one that everybody always gets. It's not, you don't say parentheses, or you don't say, something. You say, the quantity up. Now, when we're graphing this out, here's a line. We're going to say that has a slope of 7. The domain on this is going to be all real numbers because every input is used. Furthermore, the domain is the inputs, the x's. Every x gives you a y. Looking at the graph, all of the x's as I move left to right are used. The range, which is the y values, and that's the symbol for all real numbers, the range is the y values. This will drop down going to negative infinity, meaning no matter how low I go, there's always some y value on this graph that will be there. This graph rises forever, or is unbounded above. That means that it goes up to positive infinity. So we would go through and
Good
say...
morning, and please excuse this interruption. At this time, the hold in place has been lifted. Again, I repeat, the hold in place has been lifted.
Now,
thank you for your cooperation.
When you do this, have you all worked with interval notation before? Yes or no? Okay, maybe. All right. When we talk about interval notation, another way of giving this out is stating the domain in interval notation. If every number works, an interval goes lower bound, comma, upper bound, parentheses if the value is, if you have an open circle there, or if you can't hold that value, and it's a closed bracket if there would be a closed circle there. So since every number works in the domain, as I go out to negative infinity, I'm always going to be plotting something, so my domain is negative infinity. As I go out to the right-hand side, it goes on forever, so positive infinity. Every number is used or encompassed in that interval. It goes lower bound, comma, upper bound. In terms of range of this, we go through and say, all right, here's my range. It goes down forever or is unbounded below, which means the range is negative infinity, and it rises forever, so that means it goes to positive infinity. One thing to remember is this. Some of you will probably be asking, why aren't there brackets at the end if it goes out to positive infinity? You know how far it's going to. There's what we call the apple test. If you can go through and hold that many apples, then it's a number. You can hold 1 billion apples. You have to have gigantic hands and a hell of a lot of apples. But you can have 1 billion apples. Can you have infinity apples? No, because infinity is not a number, it's an idea. So we always put parentheses at infinities, and if there would be an open circle. The more we work with it, the easier it will be. So have you, let's just simple, raise your hand. Have you used this notation before then? Yes? Okay, 8th grade? Terrific. Take a look at what's there. This is a relation. Looking at what's here, hands up please if you can tell me what you think your domain would be in interval notation. Look at the x's. What x's are used? We've got one person that can tell me. Jason?
All real numbers so that they can't see all that easily.
Yep, we could go through. We'll give it out as an interval. All real numbers means going from negative infinity to positive infinity. This is another personal pet peeve. Always put a sign in front of your infinity. On the Math Excel homework, they don't ask it for you. If you're doing it out by hand, though, I ask that you do it. How about the range? This is the one where it's a little bit more interesting. Remember, it goes lower bound, comma, upper bound. We got 4 of you, 5 of you that can tell me what the range on this would be. What do you think? Now, and you're absolutely right. So far, we're good. It's 0 out to positive infinity. Who can tell me, please, am I going to put a bracket or a parentheses at the 0? Hands up, please, if you can tell me which one this would get. There you go, because the graph doesn't go up to, it goes through the 0. Now, over here, this would, just so we're aware, this would not be a function. Hands up, please, if you can tell me why example 4, this relation is not a function.
Every input has like 2 outputs.
You said something in there that's not right, so I'm going to say no, but you are very, very close. What did you say again? To make sure that I heard it right.
Like some can't have more than 1 output.
Let's be more specific. Which one is giving you the problem? Which input is the bad one? There you go. So we would say not a function. There you go. That's why it's not a function. Another thing that we're going to talk about, and this might make a really good test question someday, are all the available output values used in this graph? Are all of the available y values used in graphing this function into? Yes or no? Yes. We go down to negative infinity and go up to positive, and that's what's available to us. So this graph will at some point hit every single y value. That means that it's onto. Take a look at this function here. Example 3 is not onto. Hands up, please, if you can tell me why example 3 would not be an onto function, while example 2 is an onto function. We got 3 of you. 4. What do you want to say? Yeah, we don't use every available output value. If this, well, let's say this, is example 4 an onto function? And this, again, this is going to be the one where you're like walking into a screen door. Is example 4 an onto function? What do you want to say, please? No. Why? Oh, I'm sorry, I didn't even see that. Let's say I'll draw this. Sure. Okay. Now is it onto? There you go. It's not even a function. How can it be an onto function? So if it's not a function, you don't need to worry about it being an onto function. Now, the things that we need to make sure that we know for domain is that the domain is all usable inputs in a relation, and the range is all of the used or arrived at output values or y values that you would use. Don't get married to the fact that there's x's and y's. It could be a's and b's. It's whatever. It's input then output. So we don't need to go back. We already did. Questions on that? State the domain and range of each of these. Well, here's how far out these are going to go. So let's go through and get all of these gone. State how far out these go. Go right now, please, and state the domain and the range of each of those. You can give it out in interval notation, please. Allison, oh. All right, Allison. Do you want to do the domain in A or the range? All right, what's that going to be in interval notation?
Square bracket, -4,
How about Eli? What would you go through and give for your range?
Square bracket, -2, 2.
There you go. So bracket -2 to +2. Now the next one's going to be, yes?
I thought that we'd use the fancy bracket.
No, that's if you're listing out ordered pairs for a relation like this. Okay?
Oh.
Because those were individual points. Taking a look at B, this one's going to be, yeah. Yep.
If both the arrows are using like the x-axis for the range, maybe the range is using y.
Yep.
So
what you're talking about for B? We'll get to the range, because the range on this one's interesting. Who can tell me, though, what our domain would be in interval notation? Can you give us the domain?
Bracket 1, comma, infinity.
That part's right. There's more. Who can give more to this? We're falling for it. I labeled it, and you guys fall right to pieces.
Oh, I'm in 0.
We got to make some modifications here. This piece, there's sort of two pieces on this graph, right? That's not continuous. It's called discontinuous. Negative infinity up to 0. Now, does it include the 0? No, so we'll put parentheses. Now, over here for the second piece, we're going to have a u between them. That's the union of sets. And then it resumes again at 0 out to positive infinity. Now let's ask this question. What value is not in the domain then looking at that? Everything but 0. Now, looking at the range is where it gets fascinating. What output values are used or plotted when I construct this graph? We got one person who can see. 2. What y values are used in the making of this graph? What would you like to say?
The square bracket, negative 1,
So you said this? Is that right? Yes or no? Okay. That's close. You're saying something in here, though, that is not true. We got 3, 4 of you. What would you like to say? No, it does. You are plotting, like right here, the y value is a negative 1. What do you want to say? Nope. If I'm looking at, oh, you're saying that this does? Yes. That's saying everything between negative 1 and 1 is used. Looking at this, I'm using a negative 1 here and a positive 1 here. Is there anything else that I'm using? No. So, if we were going to list out what the range would be, you would say that it is bracket negative 1, and you're using one other value, and that one other value is 1. I guess that would be how you'd list it out in interval notation. But it's really, really awkward because you're saying, well, what y values are used? Is anything in this middle region here used? No. You're only using 2 outputs out of the infinite number that you have. And the reason that you got to make sure you pay attention, I labeled my y's, not my x's. And everybody falls for it all the time. Which of the following are functions? What about, this is from, I shared this with a friend that works at Fayetteville, so she was a little bit biased when she made this section. Function, every element in the domain corresponds to 1 in the range. So as we're doing this out, here's A, here's B. Which one of these are going to be functions? Well, to start off with, look at A and B. Is A going to be a function? No. Why? Because of February. February ruins it. So this is a no. How about for B? Is B going to be a function? Yeah. Does every input have one output? Yeah, maybe we'll list that out on the side, so we're just taking a little bit of a refresher here. This is a function. We'll say at most one output. It's possible for it to be a function if the input doesn't have an output. Is this an onto function? Not every available output is used. Is C going to be a function? Let's say Schrader students to guidance counselors. Is that relationship a function? Yes or no? Yeah, because do the students have more than one guidance counselor? No. How about the guidance counselors mapped to the students? Is that a function? Hands up, please, if you can tell me why this is not a function. Hands up, please, if you can tell me. Use your words. What do you want to say? There you go. Every guidance counselor is going to have more than one student. How about for question E? Is that a function? Yes or no? Hands up, please, if you can tell me that. Two of us. Yes, we want to say.
Every input has one output.
There you go. This is a function. Every input has one output. Let's bounce ahead. Are these functions? Go through right now. Hands up, please, if you can tell me for A, whether or not that's going to be a function. We got 3 people, 4. What do you want to say? What about for B? Hands up, please, if you can tell me if that's a function. Remember we talked about vertical line test? That's the easy way with the graph. Just draw that vertical line. Now, yes?
What was it? What was D and E on the last page? Let me get to it.
D, guidance counselors mapped to students, is not going to be a function because the guidance counselors have more than one student assigned to them. From guidance counselor to student, they have multiple. And then for E, that is a function because every input has one output. 0 gets mapped to 5, 3 goes to -7, and 2 goes to 5. Take a look, please. Now, we're going to write out and get you used to giving things in function notation. All of these represent the exact same function. What they're telling you is, I'm going to take some input value, plug it into the function, and get out a new output value. Not necessarily a new number. This would be your range. The input is called the domain. All of these notations mean the exact same thing. This, and we use F a lot of times, but you have to understand this. When you're doing a paper, and a mathematical paper, this is where function notation came from, and you're referencing 12 different equations, you don't want to say, well, the third equation is this, or you don't want to keep rewriting it over and over again. That's why you go through and use function notation. They start at F, then sometimes it's G, and then sometimes it's H, but in reality you could go A of X, B of X, C of X, D of X, H of X, Z of X. The only one that you don't want to use is X of X. This tells you what the function name is. That's the input. So the function of the input is equal to the input cubed plus 3. All of these mean the same thing. The ones that you all are going to see standardized from the REAG are these two here. However, they are all viable in the same equation. This is saying for the function for the function f, we input x into the equation x cubed plus 3. Over here, this is saying x input into the function f would be x cubed plus 3. They mean the exact same thing. Questions on that one? Let's bounce over then, please, to this. We're going to go through and do some of these on our own. Now, another thing that we have to get used to is working with the right terminology. So if I'm listing this out, I would go through and say that g of x is defined as the square root of the quantity x minus 3, not g of x is the square root of x minus 3. Because as it said, g of x is the square root of 3 would look like this, square root of x minus, square root of x minus, are those two g of x's the same? No. So make sure you say the quantity of to denote what goes inside the parentheses. Now, we're going to evaluate out g of 3 to start, and when you have a function, you always need to show the replacement in. You're going to plug this, and whatever it is in this spot is the input. It could be a star. It could be a smiley face. It doesn't matter. So when we do this out, g of 3 would be equal to the square root of 3 minus 3, which is the square root of 0. You all stammer over this constantly. The square root of 0, or what times itself gives you 0, would be 0. The next one up, you've got to go through and take the square root of the input minus 3. So in this case, that would look like the square root of my input minus 3. And in this case, my input would be m plus 3. And I'm going to want to simplify that down. Oh, sorry. Already I'm wrong. M squared. Notice, by the way, did we write the square root in, or was it given? How did it get there? Did it start there, or did we put it in? You start with it. Now, that's going to affect how we go forward. As of now, I can simplify down. This would be the same as the square root of m squared. What you need to understand is this. When you take, or when you're given a square root, and you take the square root of something squared, it's not plus or minus. It's the absolute value of it. If we took the square root, if it wasn't there to start, and then you take the square root, it would be plus or minus. Since it's given to you, you know that it's there. You're taking the absolute value of it. Go through right now. Well, we'll try this one. For for G, you've got the square root of 0. 0 minus 3, which would be the square root of negative 3. As of now, that doesn't exist. This, by the way, and I don't know if you've done this before, the expression under a square root is called a radicand, so you need to make sure that you know that as well. That's the square root of the quantity x plus 3. Yeah.
For C, would you say that G of 0 was 3i? Or, sorry.
We haven't done that yet.
Not 3i, sorry.
It would be I root 3, but we haven't done that yet. We're in the real number system. For C, isn't, because what's our input? 0. So then what's 0 minus the 3? Because that's how we define the g of x.
Oh.
Yeah, it's the same throughout. Yeah. Does not exist. Now, we're going to get, and there are ways that we can deal with this going forward. So later this year, we're going to learn that technically that does exist. We'll find out what it ends up being. But what you have to understand is this. 0 is not in the domain of the g of x. Who can give me another value of the g of x that wouldn't be in the domain? Think about what numbers can I plug in that I'm not going to have in my domain. What do you want to say? Negative numbers for sure are out, so -1, -2, -3, all of those won't work. 1 is not in the domain. You can tell me another number. 2. Is 3 in the domain?
Yes.
Yes, because you can take the square root of 0. Now, I want to make sure that we finish. We may bounce back to some of these questions. G of b is equal to 5. We need to find all of the values of. We can go back and do that in a second. I want us to get to when we're going to look at some graphs. A function malfunctions or doesn't yield an output when the x value results in the square root of a negative number or a negative radicand. So that's one time that we're going to get a function breakdown. You're also going to get one when you're dividing by 0. So that's a rational expression. Keep in mind, this is a nice way to remember this. Where the 0 is, this is okay, this is not. If your fraction looks like that, you're okay. If the 0's in the denominator, you can't. We're going to find the domain of each of these, sketch the graph to determine. Now, I'm going to say this. We'll look at the graphs in just a second, but look at what's there. And we're going to start this year talking about parent functions. This function is a manipulation of a base function, and that's going to be the square root of x then plus 2. What that means is I'm graphing the square root function but then I'm going to shift it up 2 units. That's what the plus 2 causes to happen. And again, as of now, we haven't done more than that. But when you look at this, you've got to be able to recognize that this is a manipulation. The base or parent function would just be y equals the square root of x. And then to that, I'm adding 2, which is going to make the y value or n value go up by 2 units. So if I graph this out, now you all can go into your calculators right now. So let's have you all do that, please. Everybody go into your calculators, please, and I want you to graph this out. Another thing, we've said it before, you should be working in, not in Scratchpad. Make documents. The calculator that you're working with is document-based and menu-driven. So make sure that you're going into, not into Scratchpad, because again, when we do this out, I can literally go in right now. Hang on. Does it clear your graphs if you're in Scratchpad as well? Okay. Yes? Or no? Okay, better. Then I'll just keep doing that. So make sure that you go through and create a new document, and then you're going to go through and graph this out. Looking at what's there, this is the square root of x plus 2. Notice the radicand is only an x. So if it doesn't look like that, we're hoping that you can go through and that you input it correctly. Now, looking at that graph, hands up please if you can tell me what, and knowing what you know about the square root function, who can tell me what my domain would be? Hands up please if you can tell me there. We got 1, 2 of you, terrific. 3, 4, what do you want to say?
All values equal and greater than 0.
Good, what would that be in interval notation?
Bracket 0, comma, positive infinity.
So you're going to sketch out the graph that's there. Make sure you show this. My domain would be bracket 0 out to positive infinity because 0 is included in the graph. How about the range on this? Hands up, please, if you can tell me what the range on this is going to be. I've got one person. We can do better. What is the range in number 1 going to be? Questions on that one? Next one up that we'll do is B, and when you look at B, let's graph the quantity 3x plus 4. If you need to go to a calculator for this, we'll send you right back over to Sprott. What's your y-intercept on this graph? Hands up, please, if you can tell me what your y-intercept is going to be. Seriously, 3 people? What do you want to say? Let's go down to -4 on the y-axis. Make sure you label your axes. -1, 2, 3, 4. So we get down here. My slope is rise over right. The slope is 3 over 1. That's your rise. And this is your right. So you go up 3 and over 1, your graph would trend something like this. Another thing that you all go through and do, not in well, I'll generalize to make sure that it doesn't happen. If I give you like a standard 10 by 10 or some window on a test, if you can fit the point and you don't, you're wrong. Some of you give me these little like nub graphs. You're like, yeah, it goes through these two, and then you give me a line. Like literally, you would give me this line. You're like, graph this line. You go, okay, it's from here to here. What? I give you all this space. Use it. So make sure, please, if you're given that, that's what you put in. How about this? Hands up, please, if you can tell me what your domain is here. Hands up for the domain of this graph in interval notation. 3 people. Emma? Hey, what do you say? What would this be? Careful. Negative infinity and positivity never get square brackets. Terrific. Do you know what your range is going to be? It hits everything. Find the domain, sketch the graph while looking at what's there for 7. Here's one that's going to be interesting. Now, hands up please if you can tell me what value is excluded from our domain. I'm not even going to go to the calculator. You should be able to look at this and tell me what value is not in the domain and what value is not permitted and why. We've got 3 people, 4 of you. Take a look at what's there, loves. You can do this. Take a minute, analyze it. What is not permitted? Think about it for a second. Where am I going to get a problem? Something shuts down. Everything shuts down for one of these values. What do you want to say? Yep. -2. Why?
If you add them, then add to 0.
And what's special about the 0? What is that called? Do you remember? Then remember what it's called when we get a 0 in the denominator? It's an undefined expression. So now, without even graphing this, I already know this. I know that the graph at -2 is going to have what's called a vertical asymptote. Have you heard have you heard asymptotes before? Okay. It's called an asymptote. Who has siblings? Let's ask. Raise your hand. Okay. Now, an asymptote is, and maybe if you have a brother or sister, they've done this to you before. Like if you're on a car trip and they go like this. Right, so you sit there and they do this, right? And what would you say? Do you have a brother or sister? Did they ever do that to you? Who's had a brother or sister that's done that to them? What do you say when they start doing that? And what do they say back? There you go. And then you punch them in the face. But make sure when you go through and do it, that's what an asymptote is. It gets infinitely close. Is it ever touching that line? No. But it gets really, really close. So when we do this, I know I'm going to have a vertical asymptote when x is -2. There's actually, if you think about all of the inputs, there's something else you should know, especially as honor students, that you're not going to be able to get as an output value. Looking at what's there, who can tell me what you can't get as an output value? Look at that expression, and what can I not get as an output value? We've got one person. Look at the fraction. You will not ever get this value as an output. No, you can get values bigger than 1. You can, if the denominator is less than 1. So if I plugged in, let's say, -2.5, I'd be able to get something bigger than 1. 0. Do you know why?
Because there's no way you can get a 0 in the numerator and the 0 range will be 0.
Think about what you know about fractions. Fractions are 0 when it's 0 over something. Doesn't matter what the denominator is. Is it possible for my numerator ever to equal 0? No. Go into your calculators, please. You're going to graph this out. So go in, please. I'd go back up, delete the one that's there from before, and then do control division to go through and get 1 over the quantity x plus 2. So we get something like this. Notice there's a vertical asymptote here, a horizontal one there. Now, let's answer this question. You're going to go through and give me out the graph. Who can tell me what your domain is here? Hands up, please, if you can tell me what your domain would be in 7A. Crickets. What's your domain? We just had a discussion about it about 13 seconds ago. What do you want to say? Mm-hmm. Good. It extends out forever to the left and right. The only value we are jumping over is a -2. How about the range on this? Hands up, please, if you can tell me what the range would be. Look at the graph. Is everything used? Is something excluded? If so, what would our range be? We've got 0 persons. 1. Yes. Really? Vicky S. Do you know what your range is going to be?
Would it be negative infinity, 0?
And then?
0.
Go through, please, and answer out question G right now on your own. X squared minus 4x plus 3. By the way, you should accurately give and state and label what your intercepts are. You can tell clearly from the graph that this is going to cross at +1 and +3. So make sure you have that down. So looking at what we've got, Jonathan, what would what would the domain be on this function? And can you tell me what the range would be? Now I intentionally made a mistake up here. Who wants to modify what answer I went through and gave? We got 2, 3, 4. Terrific. Questions on that? All right, let's do this. Take a look now. You go over to the homework packet. Now, maybe next to each of these slides, when I copy it over, you're going to want to put a check mark so you know how far you've done. But tonight's homework is page 81 and 82, which means I'm not giving you the book. Go to where 81 and 82 are, which is on the top of the next slide, where it says August 18th and the one on the left. You have to look around to see where they are. I'm sorry, that's the trade-off that we make for me spending 2 hours filling the questions for you. So make sure it gets done on separate paper, please, and ready to go next time that we have class. The other thing is, I think almost all of you have, but you need to make sure that you get your Math Excel homework done by the end of the day. I think it closes, it says it closes on the 15th. I don't remember how many hours or what time, but get it done, because today is the 14th, right? Yeah, today's the 14th, so make sure, please, you get that, your Math Excel homework done as well. If you don't, it goes in as 0. It's, how many of you have done it? Yeah, just the orientation thing. How long did it take? 10 minutes, maybe. Have a terrific rest of your day.